Okay, let's begin. Uh, Today's webinar topic is PC data logging and communication. Today I'll go over our PCI I/O cards and PCI communication cards. We'll start off with the agenda. Today we'll go over our data acquisition PCI card. Configure them. I'll show you how to choose amongst them to suit your application, and then we'll go over some applications for your PC. We'll go over the communication board selection guide, and we'll go over some applications. ICP DAS was established in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP DAS USA was launched in 2001 to support the North and South American markets. All of our products are ISO 9001 and RoHS compliant, and we're a Windows embedded partner. Our first topic will be data acquisition boards. PCIO cards will fit into most Linux and Windows machines' motherboards or expansion slots. They are chosen based on the type of slots available on the PC, and they are driver-based. There is no protocol associated with these boards. There's three types of boards that we offer. PCI being the most popular, PCI Express, which is gaining in popularity, and older ISA boards we have to support older machines. These boards are easy to install. Simply open the cover, identify the open slot of the correct type, remove the slot cover on the back of your PC. We'll go over the dip switch settings according to the manual in a little bit, in I think the next slide. And once you do this, you start up your computer and install the driver. This just shows the slight difference in the size of the slots and how to identify what type of slot you have. Ideally, if your PC will either show you what types of slots are available, or you can identify it based on a picture you can just find by Googling or look in our manual for a selection guide. And let's see, the right side picture just shows the panel that was previously talked about in the previous slide to open the cover to expose the connector slot for the PCI card. Let's see, our data acquisition boards come in various flavors or types depending on the slot type again. ISA slots, which are the older type, PCI slots, universal PCI are the same as PCI, except they encompass both the 3.3 and 5 volt bus voltages, and the newer PCI Express boards, which have the smallest slot. Let's see, we provide many different series of data acquisition boards with multiple channels, high-speed counters, and multifunction ones, which include analog inputs, digital inputs, digital outputs, and a few analog output modules as well. They support both Linux and Windows operating systems, both 32 and 64-bit. The UNIDAC driver provides easy-to-use API functions, and we have sample programs for many of the popular languages with source code to help you to create your program. The boards are also LabVIEW and MATLAB. We have samples of how to use with those programs as well. For product selection, it's fairly simple. You simply identify the PC slot type you have, again, ISA, PCI, or PCI Express. Determine the number of I/O channels which you'll be needing and the types of I/O. And then you must verify if your software or the software you're going to create are compatible. And we do have many demo programs available for each of the different programming languages. Then you use a selection guide or catalog to choose the appropriate model. Here's the link to the selection guide on our website. It's a direct link. If you start from the home page, you just need to do a little navigation. But you select the proper slot type from the web page, and you'll get a table like below. Let me show you the actual web page. I have it over here. This is actually one of the tables. This is the PCI Express table, and again, it just has the different I/O channel types and the I/O counts. So, for instance, this one right here has 4 analog output channels, and they're plus or minus 10 volts or 0 to 20 milliamps style. And just go through the table and choose the appropriate one to suit your I/O needs. And if you need more information on a specific board, just simply click on the model number and it'll bring you to the product page. And from here you can download a data sheet or look at the pin assignments or do whatever you need. And if you need demo programs, just please let us know. Okay, so for selection, we do have different tables for the different types of slots available in your PC. Here are some of the most popular cards that we offer. The PIO D24U has 24 digital channels. The PISO has 32 inputs and 32 outputs. And the PCI relay cards and PhotoMOS cards like the PCI P16, POR 16U. The high-speed models, which are great for analog inputs that you need to log at a very fast rate, are shown here. These are the most popular ones. And the highest cost performance ratio models are shown to the right. And PCI cards are, of course, the fastest for data acquisition that we offer. Here's some software support and operating system supports that we offer for these cards. They're both Windows and Linux compatible, and they're Java, LabVIEW, MATLAB, DOS, and DaisyLab have been used with these cards in the past. If you need to find out specifically for a specific card, please look at the datasheet or web page for that specific card. If you have any questions, please let us know. The Windows software development, this is an overview of all the operating systems that are compatible. Everything from Windows 2000 to Windows 10 are supported, and the UNIDAC driver, which we use for our PCI cards and PCI Express cards, provide easy-to-use API functions and support most of the I/O boards that are in the table. But you can look at the sample programs with source code to see if it's compatible or see if it will suit your application. The high-speed counter ones and analog input ones and digital cards are the most popular, of course. Here's an overview of Linux software development. The kernels supported are 2.6 to 3. If you have newer ones, please check with us to see if it's compatible. It may be, but this is just according to the latest or to one of the documents I found. It supports both 32-bit and 64-bit Linux operating systems. And again, we have demo source code for most of the functions of the boards. And if you need one, just please let us know. Here's the application flowchart. So again, the PCI board's on the right. Then the Windows operating system communicates to the DLL or library file, and then you must create or connect your driver or associate your driver with the appropriate program or programming language, and then you create your application. Your application can run and read the I/O statuses of the boards. Typical applications for our PC cards are inspection systems, high-speed counting, robotics, sorting machines, standard data acquisition, SCADA, factory automation applications, as well as dispensing, laboratory automation, and analysis and comparison applications where, for instance, like vision systems and so on and so forth can be used for these. Here's a few applications and suggested products. The first one is PC board testing machine. The suggested products are PCI and PCI Express DIO boards. These are very fast boards and can monitor and analyze the I/O status in the megahertz range. And they've been used for testing of the solder joints for the PC boards. Laser inspection. The suggested boards are shown on the bottom left. And this is just comparing the analog input signal associated with the laser beam. Let's see, in summary, the data acquisition and controls are done using the UNIDAC driver. This means that there's no protocol. Again, you must create your own program or use one of the programs which are compatible with the UNIDAC driver to use the PCI cards in your application. There are Linux and Windows operating system compatible. Most of the popular programming languages are supported or can be supported. And these are the best solution for high-speed applications. We have many combinations of analog and digital channels available. Please use the selection guide for choosing the best one. If you need assistance in choosing it, please let us know. We have a wide variety of demo programs showing everything from how to monitor the status of the inputs to controlling the outputs. And the easy-to-use API functions are available in the API manual for that specific board. And again, there's no protocol built into these boards, so it's not just where you can communicate by Modbus to the board. You need to actually create a program for these. The next topic I want to cover is our PC communication solutions. These are solutions for adding COM ports to your PC. They're very useful for industrial applications, especially with Modbus communication. We have both PCI and PCI Express, which add different counts of COM ports to your computer, as well as, in RS-232, RS-485, and RS-422 ports. And these work on both Windows and Linux operating systems. And these can be used to communicate to peripherals like barcode scanners and scales via RS-232, and are especially popular for using with our data acquisition equipment for Modbus RTU communication and PLC communication. Other applications are like configuring PLCs or talking to HMIs. These are our PCI communication boards shown here. Just select the model with the correct number of COM ports that you would like. We have everything up to 8 RS-232 and 8 RS-422/485 channels. And we also have options with isolation. Here's our selection guide for PCI Express. Again, very similar to the previous slide, just based on the type of PC slot that you have. You choose the appropriate number of COM ports and if you want isolation. Most of our PC communication boards come with dip switches on board, which provide for easy configuration and the ability to set the predefined COM port number associated with the base COM port. So for instance, if it has 2 COM ports and you selected dip switch settings for COM3, it would be COM3 and COM4. Otherwise, if you don't use the dip switches, you can always use the Windows Advanced configuration for the port setting in your device manager, but that's also shown in the manual. Typical applications, very basic. Adding COM ports to PCs. Most PCs don't come with COM ports now. So if you need to communicate to either RS-232 or RS-485 equipment, adding a PCI or PCI Express board to your PC and having the available slots on the back make it a nice and more permanent solution than using most of the USB or Ethernet converters. They also are great for communicating to Modbus RTU modules, which we also sell. So, that's a very popular application for us. Connecting to serial equipment or PC peripherals that are RS-232 or 485, and for general serial communication like to HMIs and to message boards or other applications which require serial communication. Oh, and also using cellular modems, sending AT strings to the modems for testing of equipment is also an application which we've used these for. Here's just a quick picture showing, again, the ability to add a permanent COM port to your PC by using one of your PCI or PCI Express slots. And you just create COM 10 and COM 11 in this case, but you can always set those up in your PC as well. Here's some of the common connectivity suggestions. Cellular modem or standard modem, PLCs, meters, barcode readers, and card readers, as well as automation equipment. The other application, again, is industrial data communication, which a lot of our products are used for these applications. SCADA communication to PLCs or remote data acquisition modules. Again, the PC communication boards can be used to communicate to our remote data acquisition modules with protocols. These are different from the PC cards with the I/O that we talked about earlier. Our PCI cards allow the ability to communicate to PLCs via Modbus. Modbus RTU, because it's so popular, is very commonly used with our PC communication boards. And when connecting to SCADA or data logging systems, communication can be bridged by using a PCI or PCI Express communication board. Here's just an application picture I found. It's for a battery pool test and monitoring system. These are slave or Modbus slave devices, which are connected by RS-485 to the 3 channels of the communication board, and each one just provides the status of the battery, including the voltage and the current. This is actually an application that was implemented. Probably more simplified in the picture, but it has been implemented this way where each device is just Modbus. Okay, another application that some of our cards were used in is monitoring pipeline pressure in a refinery. This is used to verify that if the pressure drops, there's either a clog or someone needs to actually go out there and open the valve or close the valve. If anyone has any questions, please feel free to ask at this time. Our contact information is shown here,